Hello and welcome to a new session in our series Architecture Design Patterns. Using a case study, we are going to demonstrate the Command Query Responsibility Segregation Pattern, CQRS. Let's get started. So, in our previous use case, when we demonstrated another pattern, the Strangler pattern, we had a monolith application hosted on a mainframe. For this case study, we imagined an airline system and they wanted to refactor and modernize their system so that they can scale out the booking and expose it to the passengers with a mobile application. Of course, when we talked about the Strangler design pattern, we introduced it in its own Archimate view, as you can see on the screen. This was the situation we ended with after the refactoring. And remember, we had a lot of APIs and communication between the on-premise and the cloud, and we have secured the communication with a VPN. One of the questions that arose about this topic, just to recap, why does it matter to do it step by step instead of modernizing the entire stack at once in the Strangler design pattern and host it all in the cloud and get rid of the on-premise legacy system? The answer is very simple and it's about cost and reliability. First of all, we don't have the budget and the time to modernize the entire stack at once. This project could take 1 to 2 years, for example, and this is not possible to be done at once. And on the other hand, the business demands that we cannot wait 2 3 years just to benefit from the scalability and the efficiency and return on investment in the cloud. So we want it now, we want it yesterday. So the Strangler design pattern fits into this scenario, a real case scenario that comes often in practice. So this is one of the reasons. On the other hand, there is a lot of know-how that needs to be migrated from the old system to the new system. The DevOps team and the developers, they are more accustomed with the on-premise environment. So migrating the know-how and getting their hands and grip of their cloud systems, this will take a while, a learning curve. That's one other argument that one needs to take into consideration when designing such systems. The arguments can go on and on. Think about why is it sinful, why is it make sense, or why it doesn't make sense to apply the Strangler design pattern and see how you can benefit it from in your day-to-day job as an enterprise architect. Enough talking about the previous situation. Let's get to the point of today's pattern: Command Query Responsibility Segregation, or CQRS. We see here there is communication between the on-premise flights APIs, loyalty, passenger APIs, and the microservice in the cloud pulls the information it needs from these APIs. And likewise, there is a get booking APIs and the booking module or booking client in the on-premise environment pulls the information it needs for reporting module and support ticketing system. So having that in mind, this pulling is expensive. How often are we going to pull? In case of reporting, this can happen once every day at midnight when the operations are not that exhaustive or extensive. So this makes quite sense, yeah. On the other hand, the support ticket system, this is on demand. When there is a support ticket, it fetches the information that needs in pull mode from the get booking APIs. So this is also not very exhaustive. However, coming now to the new use case, our marketing team has proposed we want to engage our clients of the mobile application. The passengers, they want now to be rewarded in real time when they make a booking over here, over the booking APIs. They want to see a loyalty point added to their account or mobile wallet. So this needs to be happening And as an architect now, your architecture work package to design a target architecture to enable or allow this use case to be implemented. You sit down with the different stakeholders, get on the situation, you sit with the Reality APIs team so that they see how they work and what are the time constraints so that they can really apply these upgrades to the reality points to the passengers. And you find out they have a complex algorithm in place, and this algorithm needs to go through different parameters, etc. And to do it in real time, they need to be pulling the booking APIs as well. These booking APIs I'm talking about. So this is the situation. How are we going to tackle it? Here comes in the command query responsibility segregation. In a way or another, before we dive into the target architecture, what we have here is one possible implementation of command query responsibility segregation. We have done it without naming it. Here over the booking APIs, the booking is being created, command create, or cancelled, cancel. So these are the command part. On the other hand, we have here the get booking APIs query part. We get, view, list, batch download the bookings so that we can stream them. This is actually command query responsibility segregation. We will dive deeper and see two more flavors of this button so that you can also benefit from it and apply it in your day-to-day practice. We'll start with the synchronous pattern. Here I have the passenger, and the passenger pulls or is being served by the mobile application. The mobile application itself pulls the data from the booking APIs and the Reality APIs, and the direction of the arrows, because in Archimate the server relation is pointing in the opposite direction, if opposite to what you actually may interpret or expect, but this is the right way to do the standard. So wrap your head around it. The mobile app is being served by the booking and Reality APIs. Booking APIs here means we can create and update and cancel a booking, and the Reality APIs here, it means we can get from the Reality APIs our Reality wallet and see how many Reality points we have as a passenger. In between, we have the booking service exposing the booking APIs. That means here, this Archimate assignment means assigned to, because you can see one microservice can expose multiple APIs for multiple purposes. Exactly in this case, we have the create and cancel and the get bookings for the mobile application, which is not the same way that works for the internal get booking APIs that's being used for the reporting service in a batch mode and listing and different mechanisms. The reporting service also is being served by the Reality APIs, which is assigned to the Reality service so that we can do analytics and reports on the bookings and realities. And in the previous monolithic view, we have also seen that it's assigned to the passengers and many other APIs depending on the 360 view of the reporting we want to provide. So at this point here, we have the get booking APIs pulling the bookings, apply the Reality algorithm on them, and then this Reality APIs exposes them to the mobile application. Again, we said this synchronous mode, it means it's expensive. The pulling happens every minute, every 2 minutes, every day. We are not sure how the algorithm can wrap this time lapse quite well so that the requirement is being fulfilled. We want to say the passenger needs to be rewarded immediately. So immediately here, are we talking about 30 seconds? It will become even more expensive. So this pooling now and synchronous communication of the APIs is simple to implement, more exhaustive in terms of resources, CPU and memory of the APIs. Of course, you can add caching, etc., but then you miss the point of having it real time. That brings us to the second flavor of the command query responsibility segregation pattern, the asynchronous way. And asynchronous here, it means we need a message broker. You can see here everything is quite the same, but we introduced a new component. A message broker, it could be Kafka, it could be message bus in Azure Cloud, it could be Event Hub, it could be many other variants of the message streaming systems or event streaming systems. And this message broker here is a Kafka topic for the bookings. The booking service, once a booking is created or cancelled, it triggers an event, booking event. Booking event contains the inquired information, the booking ID, timestamp, the passenger ID, the booking, the flight, the amount being paid, etc., etc. And we have here two options. We can keep the booking event as minimal as possible. That means here is actually an alert, a notification. It just says, hey, subscribers, be aware, a new booking has been created. If you're interested, you can pull my APIs now. That's one way to do it. Or it could be self-contained. It has all the information needed as a booking, as long as this fits as according to the maximum message size in the Kafka topic, then this is also possible. Now comes a question of storage cost. It could be marginal, but if you say we have millions of booking events per second, then every byte will count. So be aware, you have here two options. So this option now, we trigger the event. The Kafka topic has now a consumer group of the different subscribers, not a consumer group. Consumer group is something else used for partitioning. When we have multiple subscribers of the same service, we want to ensure that the message is consumed once by the service or one instance of the service. So we have consumer group. That's a different concept. Just you can review it on the Confluent Kafka documentation if you're interested. We have here subscribers, reporting service and loyalty service. They are both subscribers of the Kafka topic. They are now being consuming the event from Kafka. Kafka is designed for this mechanism with efficient pooling every milliseconds, and then the message is being consumed with message retention. You can have dead letter queue when it's failed. You have retries mechanism implemented in the client. This is all one of the benefits and advantage you benefit from this architecture. On the other hand, when we consider the cost of Confluent Kafka maintaining the service, if you have self-managed service or if we have a fully managed service, this is another cost dimension. Be aware of these limitations as an enterprise architect. It's your responsibility to outline the risk, the magnitude and the frequency of the risk, the advantage and disadvantage, pros and cons of every solution. Make the stakeholders aware of the trade-offs you are making in your target architecture. And then the events are being consumed by the reporting service and loyalty service, which in return consume the get booking APIs, and this way they perform the algorithmic in real time, near real time, name it as you want, but this is as real time as it gets. And then you have here the reporting also consuming the get booking APIs the same way and consuming the event. This is a plus, since now the analysts team have come up with a requirement. Hey, we are interested in having real-time analytics for our management board so that we can give them an up-to-date view of our sales and revenue and return on investment. So this also has played quite well in our interest that we have introduced real-time analytics and real-time loyalty system, so the passenger now are being rewarded immediately when they made a purchase. Quick recap, we have introduced in this session the command query responsibility segregation pattern. This has demonstrated in two ways. One way, when we have the cancel and create APIs separated from the get and batch download of the bookings. Another way, when we had the booking event being created in one branch and then being consumed or queried in different ways by different services according to their needs. This is also one of the possible target architectures. There is an related pattern quite relevant, which is event sourcing. An event sourcing says that the event can be reconstructed to view the entire history of the transactions being performed in the system. This is quite interesting because it can also be implemented in this way when we have the booking events being sent over the booking Kafka topic, and then the reporting service aggregating all these notification logs, the updates, the creates and cancels, to recreate a history log of the booking for a specific passenger. This can be also be applied to the loyalty and passenger services, support services. However, this is a topic for another session, but now you are being informed about this possibility as well. Thank you for listening and see you in future sessions.